Hi everyone. Hello chat. I should not be monitoring my own stream. The chat should be showing up there. It would have showed up there. Surely would have. Cramble. The functional stream. Hi Jake. I'm not late. I'm starting at 11:59 a.m. I'm early. Early bird. We are going to write more functions today. I might quit a bit earlier than last stream. I don't think I might play some Flashpoint stuff, but I don't think so. Um so we've got some exercises on OCaml's website. I had started doing some of these and I think I'm gonna do some more of them. Tail of a list, last two elements of a list, nth element of a list. So we can start out with tail of a list and start out by writing some tests. So I got my let underscore equals assert, and that's just true. So it's just, you know, it it asserts that true is true. So yeah, but I can write a function to assert that. No, I can write a test to assert that last, provided this list is equal to some d. Yes. So, all right. What would I do here? So in order to write my last function, I'm going to do let rec last. I'm going to take in a list of any kind. It doesn't necessarily have to be a string list. So by that, I'm going to take in a tick A list. So I'm going to call it a LST tick A list. And then I'm going to output a tick A option. So what option is it's like a type where it's either none or some x, some tick A, because it's a tick A option. So I'm gonna do that. So I'm gonna match on the list with x prepended to the empty list. Yep, that would be x. Since we're looking for, it would be some x, right? It's really OCA's my ML. Hello, not Abraham Lincoln. Yep, hello, Cramble. OCaml time. It really is OCaml time. So the base list, we're gonna return that with none. So this is going to match the last element of the list because this is the element and this is the last gosh darn it, this is the last, that's the base, that's the empty list. So right, so if we were just to like s const with an empty list, it's just a list with s in it. And due to how like these recursive calls work, so this is our recursive case, x const with xs, it just runs last xs because this would indicate that like there's more in the list. So it's going to run the last function again with the rest of the list. I'm just going to write rest. It's easier to understand. Oh, really? BOGO sort. That's really good. I don't think it does. No creo. No creo que sí. All right. So last, and then run it, and then test is good. Que mal, que mal. All right, and then test it with an empty list. Yeah, it has a yeah. All right, last of an empty list. Quality to none. Does this game have achievements? Yeah. Yeah, it's if you can get to the bottom of this page, then you win the game. I'm sorry, I'm gonna need to translate that that JavaScript for the rest of the chat. I just called Japanese JavaScript. All right. So we're back up here. Our tail of a list function works good. Trackmania no camel? Yeah, I'm sure. I think it would be pretty good. Last two elements of a list. So this is going to be similar. So I'm gonna copy what I have. Doritos Crash Course and OCaml would be awesome. We were joking about Okami being written in OCaml yesterday because Cabby was streaming Okami. Okay, last two. LST tick A list and then tick A option. Maybe, I think. Yeah. So true. Okay. Some, and that's gonna be like a tuple, right? And then it's like gonna be X, Y. I'm very good at explaining my thought process. This is really, um, type variable tick A occurs within inside tick A, I tick B. Rubber duck debugging stream. Yeah, that's what this is. That's what this is. Might do some Flashpoint later, but I'm really not counting on it since I have stuff to do later today. String by string option. Okay. Expression was expected of type string. Okay. Okay. Oh. I'm so busy today. I'm really busy today. I wasn't sure I was gonna stream today, but I figured, why not? Whoopsies. That's me looking at the solution. Wait, that was for the last one. This is the solution of this one. Try to figure this out. Empty list. So it matches the empty list or a list with one element, and then it returns none because it's supposed to return the last two elements of a list, and not having more than one element of the list is like a bummer. Okay. Okay. Uh, yeah, all right. So matching a list with one element and returns none. And then I would guess that's, oh wait, x rest. That should work. So last to rest with the rest of the list. Yeah, well, I didn't test it. Didn't write any tests. But here are our tests. Could probably just write them. C D, and then I'm gonna match it with a list with one element and ensure that that returns none. And then match it with an empty list. Make that return none. And then, yeah, there we go. Oh, I should probably break the terminal down. So our last function gets the last thing of the list. It matches the list. If it gets the empty list, it returns none. And that's what it's going to do by the end of like, oh, well, if it finds an element at the end of the list, const with the empty list, it's going to return some x. If it matches x and then like a list that's not the empty list, so that means there are more items to process, it's just going to feed that back into the function. And it's similar with last two, but it matches a list with one element and returns none. And then it tries to match the last two elements of the list and returns it with as an option with some x and y tuple, or a string. String times string is a tuple with a string in a string. And hello, hi Kevy. And x const with the rest of the list, last to rest of the list. You know, it's an arbitrary name, but it matches the last two. And we load the file, and because we've written these tests and they pass, it does that. If we were to try to prove that like it's equal to some like this, it would like fail out. But our tests are good. Our tests are correct. So the nth element of a list. This is okay. This is interesting. This is interesting. This is going to be an interesting bit. So find the nth element of a list. So we need to accumulate something. Oh, thank you everybody for tuning in. So the list that we pass in, and then the index as listening and learning, and then it returns tick A option. Tick A option because it's either not there or wait, actually, let's not use. I'll not use option. I'll just raise an exception if it's out of bounds. So red bubble. Oh no. Oh. And so an nth list match list with Actually, I'm gonna write a helper function here. Nth helper list index int, and then like another one for the current. No, I don't need. Okay, I don't need to add another. I don't need to add another index. Current. Okay, list. Take a list. Um. Take a. Yeah. Listen. I'm a social media influencer. I'll soon be able to retire. So, man, X, rest of the list. Nth helper, wait, when current equals index it's X, right? Otherwise, X comes with excess when current is greater than index, that's going to raise an exception. When I remember how to raise an exception in OCaml. I should remember how to do this. Raise, oh yeah, raise failure. Out of bounds. Okay. Okay. And then, I don't know what's up with matching a base list. I don't remember. Okay. XS. And then feed it back into the function because it's not reached the current one. LST current plus one. So now that we've defined a helper function, I gotta use it with in and then call, but use that function with the lists. Yeah, OCaml's pretty cool. I think it's pretty neat, really. I don't know if I need the double argument there, but I can try it and see that it works. See if it works. Partial match, there's a case that's not matched. See, but like, I don't know what to... I'll just raise an exception. Failure. Whoops. No elements in the list. Because if we're trying to get some nth or some n element in the list, whoops. 499. It's my current file. Nth list. And I'm gonna try to get A, B, C, see if it'll let me get the 0th element. Yep. Okay. A. Oh dear. No, I need to return the rest. Yeah. Yeah. So I return the rest of the list into the helper function, and I increment the current index. No elements in the list. Okay, yeah. So this is just that's just out of bounds. OCA. OCaml Transit Protocol. Yeah. There are like OCaml like frameworks you can use. I don't know how they work, but they're definitely a thing. I can't say so much for front end though. Actually, no. I think there's a JS of OCaml, which is like a JavaScript runtime for OCaml. They might be able to do something there. And I'm sure there is an HTTP server for OCaml for sure. All right, so throw some tests in here. Throw some formal tests in here. Fill your nth. Might as well just copy that. Yeah, I'll just keep out of bounds. I wonder if just commenting that when current is greater than index, I wonder if that'll just work. Yeah, so I don't need that extra when clause. Just when it reaches the base list and it hasn't found when the current index is equal to the desired index, it'll respond with out of bounds. And then if it hasn't reached either of those points, it'll just keep calling itself, calling the helper function until it gets there. So now I'm just curious if I don't even need to define this like argument there at all. Oh wait, no, I do. No, I do. Because I need to feed the rest of the list into that into that list. Sec. Okay. And then length of a list. So this is just going to be an incrementing integer. I had to take out a Redbox DVD. All right, length function is true. Don't need an index. And then let rec length helper lst pick a list count int. And this is going to work pretty similarly to our nth list. And so it's going to match the list with base case or empty list. It's going to return actually the count. And then that's what we really care about. So it's just going to match. Well, it doesn't really matter. We just feed in XS. Actually, I can use the underscore here as well. I'm going to use the underscore. Yeah. Because we don't need to give a name for that. For the rest of that like line. So matches anything with the rest of the list. It's just going to feed it back into length helper, feed the rest of the list, but it's going to increment count by 1. So it's going to feed in count but plus 1. It's going to do that like recursively. 374 for Bert CD with OCaml on it. Yeah, absolutely. And in length, Harry Davis would have totally approved of this. Absolutely. LST, start from 0. And then Temple OS stream. Temple OS stream. I'm just testing this manually. Okay, I'm giving it a, blank list, a list with 3 elements, and yeah, that works just fine. You ever written a compiler? You ever written an interrupt routine? Yeah. Yeah, all right. And then reverse the list. So reversing a list is like Yeah. Okay, let rec rev lst decay list decay lists, yeah. And then let rec rev helper. I don't say bad words. Only very occasionally. I'm not gaming right now. I'm writing OCaml LST and then accumulating list. Yeah, sure. We'll go with that. And then decay equals and then match LST with base case. It's gonna be when the base case when LST when the amount of like elements to reverse is like empty, we're just going to return the accumulating list. Otherwise, we match x cons xs rev helper the rest of the lists and then accumulating list. So x cons the accumulating list. And then, now that I've defined that, I can use it as rev helper, lst, and then give it an empty list to accumulate on. And hopefully that's gonna work. I said hopefully that's gonna work. Okay. I didn't type in tick a list as the return type. All right, and then so try to reverse, it's an empty list, nothing really happens. Let's have a list of characters A, B, and C, and then it's CVA. Oh, there you go. Because so this cons operator is like prepend to the list, so it just keeps doing that, or it just keeps passing what's left to go and then what's been done back into the function. But yeah, this prepend. This is a prepend operator. Cons is a prepend operator. Could do like this, if as far as I understand, to append it instead. So if I did that, I guess I'm wrong. Unless it's like this order, perhaps. Yeah, there you go. So if you didn't actually want to reverse the list, that's what you would do. You would append the accumulating list to. I don't know what the point of that is, but you can do it. All right. All right. So moving on. Palindrome. Find out whether a list is a palindrome. A palindrome is its own reverse. Interesting. I think I had done this before. But I don't remember how I did it. So I'll try it again. Let rec is palindrome lst tick a list let rec palindrome helper lst accumulating list. But I think what we're supposed to do here is actually I'm gonna try it. Yeah, that's what I'm. Wait, I think that's a way better idea. That's a way better idea than than what I was going to do. You're right. I was thinking of like, okay, what if we like add up the elements of the list to an accumulating list, and then during that process check that the accumulating list is equal to the list itself. But you're right. It would just we could just do lst equals rev lst. Thank you. No, it's a returns a boolean. Bool. Return the bool. Watching without audio. I didn't realize that was a thing you could do. Like, see when someone is watching without audio. Okay, but yeah, this is our is palindrome. So test it with that. True. That works. Not is palindrome a list A, B. True. So yeah, that works good. Awesome. So that, let's see if there are like more like beginner ones. Unless that's just it. Unless there are just different categories or something. Oh goodness. Run length encoding. If you need so, refresh your memory about run length encoding. Okay, so I think what's going on is it's like, okay, it's counting the instances of each of the objects in the list. Okay. Wikipedia page. All right. Run length encoding is a form of lossless data compression in which runs of data, consecutive occurrences of the same data value. Okay, consecutive. That's the key here. Are stored as a single occurrence of that data value and a count of its consecutive occurrences rather than with the original than as the original run. Okay, I'm gonna try it. I'm gonna try it. All right. Rec encode LST pick a list. And it's gonna return int by pick a couple. That's a list of those. Okay. So is this accumulating though? Do I need to write a helper function? Probably write a helper function. Just to oh yeah, occurrences. Hoping I spelled that right. Occurrences, integer, and then yeah, I'm curious how this is gonna work. Match LST with base list. Well, that's going to be. Oh, wait. Okay, wait. Scene is of type tick A, and occurrences is an integer, and yeah, something accumulating lists. Int. Okay. This is a lot of parameters, so I don't know if this is like what I should actually be doing. But this could be it. This could be okay. So LST, we're matching it with like a base, which would mean like no more to like encode, and then um excess when when x is not equal to scene, right? Like, okay, yeah. Okay, something like that. Or no, when x is equal to scene, it's going to be like encode helper xs x, or scene x. occurrences plus 1. And accumulating list is not going to actually accumulate it yet. It's just going to pass the list that's accumulating further. And then when it runs into an X that's not like equal to the last scene, it's going to do encode helper, pass in the rest of the list. The new scene, and then occurrences 1. And then the accumulating list is going to be, it's going to be scene. No. It's occurrences scene const with accumulating list. Yeah, okay. That might be what I'm trying to do. And then in encode helper. What does it do with the? Okay, wait. In match LST with, so match right away with, if it's an empty list, we return back an empty list. But if there's items, encode helper, we pass along excess, the, yeah, come on, Jake. You're missing out on so much riveting commentary. All right, so X is seen, occurrences is a 1 when you run into the first element of the list, and then accumulating lists is going to start as an empty list, and I believe that's going to work. I think that's going to work, and it would be very, very cool if it worked. So no type errors or anything. He's not listening or learning. Come on, Jake. Can't believe this. When'd you know it? It actually worked. Wait, is it the right order though? It is. Wait, is it? I don't think it is. I don't think it's the right order. Why is it? It's supposed to be this. It's supposed to be this. Why isn't it that? Oh wait, is it? It's reversed. It's reversed. Okay, so like I'm gonna try and do what I just did like before to prevent it from coming out reversed. So I'm going to append it to the accumulating list. And then oops. And then yeah, there we go. There we go. Yeah, perfect. My encode function is really good. My run length encoding function works perfectly. No problems at all. Let me compare it. I want to compare. I want to compare it with what they got. I'm just gonna like put that in there. So they just did list.rev at the end, which I could have done. They used an if they did this. That's right. Not too familiar with that. Not too familiar with that. Grouping. I think it's like matching a sublist or something. I don't really know for sure. I'm not too certain. Not too sure. I am Steve. Yeah. Minecraft movie. Same year as Shrek 5. Okay. Cool. Functional language bros. Modified run length encoding. So this one, what this does, if an element has no duplicates, it is simply copied into the result list. Oh, so it's like one, it's one or it's many. Functional programming buddies. Yeah. Okay, so, all right. So I'm putting this type in here. So this RLE type is one of some object, we don't care what type, or it's many of a tuple that's a tuple that's an integer and then that type. So I'm just gonna copy this stuff in here, encode better, encode better, and it's gonna be so when. So first of all, our output is going to be this type. So it's going to be a list of this type, RLE list. That's going to be the same for the helper RLE list. And this part's the same because at the very end, when it's like done, just gonna output the accumulating list. This one x equals scene is probably going to do that again. Or yeah. When so this is after. Okay. So when occurrences equals 1, it's going to. So like this case is when the element that we just got is the same as this element that we saw before, the same as the element we saw before. And then that's a recursive call. We just keep going to see if we see another one. And then this one down here that we wrote before is when the x is like not equal to scene, because otherwise it would do that here. But so I'm adding another one that's when occurrences is equal to 1, and this would only get matched if the element that we just saw is different than the element that we are taking in now. So when occurrence is equal to 1, I want to append one scene. Otherwise, I'm putting in many occurrences scene. And then if I reload my file, specs1 x. Oh yeah. Pick a RLE list. Since this type is of another this is a type constructor for like an existing type or something. And oh yeah. Yeah, this has to be the same as this. Okay, all right, encode better. So this is using the custom types. So many of 4 and of A, and 1 of B, many of 2 of 3 of C, many of 2 of A, many of no, 1 of string D. So that's the better version of the custom type. And this is what they got. This is what they got. So encode L equals create tuple. Okay, interesting. So this is another. They used another function, made a separate create tuple function, and they called that. Interesting. Interesting. Very interesting. Create tuple. Print the count element. If the count is equal to 1, then 1 element. else many count and then the auxiliary function or the helper function. Base case empty list goes to empty list. One item in the list. Oh, okay. So this matches a single occurrence, like a single occurrence, unless it can find multiple occurrences or something. Something like that. Something like that. I don't know. Head cons with second cons underscore as the tail. A little hard to just look at it and figure out what's going on. Head is equal to second, then sends it back in there, accumulating. Yeah, I am too. It feels a little more like complex for me. Else auxiliary 0, count 0, and that would, I guess, go through the rest of the. Yeah. Okay. I'm gonna move on to duplicating the elements of a list. Duplicate A, B, C, C, D. Oh yeah, this is simple. This should be pretty simple. So duplicating the elements of the list. Let rec duplicate. I'm sure create underscore tuple would be better placed by the definition of TKRLE than inside the encode function. I'm not sure if types would allow for that in OCaml. Not too sure, but maybe. So duplicate TK list. TK list. I don't even know if that needs a helper function. Because it can just be like X and then XS for the rest of the list. Duplicate XS X cons X. I'm not sure that it would. Might be like that. Maybe. Duplicate A, B, C. Yeah, A, B, B, C, C. Cool. I'm just curious if the parentheses there matter. I think it might. No, it doesn't. Okay. So it just duplicates each thing that it sees. Or it just, like cons X twice to the result. And is that how they did it? That's basically how they did it. They named it like H to T, and I probably should have done that as well. But these are the same function basically. I just have a habit of writing the match LST with because this function here is like a shorthand, and also they didn't define the types strongly in their examples, but I'm doing that. So LST is of type tick A list, and then the output is tick A list. So yeah. split a list into two parts. So like the first part is given. Oh, I'm not sure. I could probably do it. I'm getting a little tired now. 50 minutes of 50 minutes of OCaml. 50 minutes of OCaml. What should I do? I should do something else. I'm gonna do something else. I should cap it off with more Zuma. Yeah, my brain might melt. Alright, I'm gonna cap it off with more Zuma. Hold on. I gotta get Zuma set up. And we have many options to choose from when it comes to different Zuma games on Flashpoint. I should actually like get Zuma Deluxe installed. Okay, I can play Zuma's Revenge though. All right, that's what I'm going to do. Yeah, pure functional programming action. Okay, no, I'm just surprised that like I didn't have to reconfigure anything. I just opened the game and my setup just worked. I'm so happy. All right, I'm gonna turn on desktop audio if that makes a difference. I don't know. I'm gonna play. All right, the basics. All right. Sorry to anyone who expected more OCaml. All right. Oops. All right. Oh no. Made a terrible mistake there. All right, level 1. All right, level 2. Oh no. I didn't do that. I didn't do that. That didn't happen. Pro gaming. I'm in the big leagues now. All right. No. Arg. Level complete. Level complete. Alright. Level 3. Oh my goodness. Shiny thing. I gotta get the shiny thing. I got the bonus. I got the bonus. Alright. Alright. Alright, level 3 down. Level 3 down. Oh, okay, wait, no thanks, continue. Okay. Alright, we're good. We're good. Oh. We going. We are going. Oh my goodness, a 4 times combo. Aw. Ooh. Yeah. Arg. Getting a crazy chain bonus right now. I'll have to lose it. What? Oh no. Oh no. Okay, alright, we got another chance. We got another chance. I got 2 lives left. I think it's okay. I think we're good. That was scary. That was really scary. Oh. I almost clicked outside the window. Otherwise I would have gotten the bonus. That's okay though. I'm gonna win. I'm gonna do super good. That didn't happen. That didn't happen. Oh dear. Oh. No. Oh. Oh. Oh no. Okay. Good, good, good. Good, good, good. Uh. Oh jeez. did it. I did it. Level 4. Alright. 1 life left and we're on level 5. Wow, that was lucky. Okay. Alright. Oh my goodness. This is a short path. Chain bonus. No. No more chain bonus. Oh jeez. Oh no. Oh. Okay. This one is so freaky. It's like inside a volcano. Oh no. Alright. Level 5. No thanks, continue. Level 6. Oh no, I clicked outside the window. I clicked outside the window. Alright, hold on, menu. Okay, alright. We're okay. Um, oh, I'm doomed. I'm so focused right now. Locked in. I'm locked in. I'm locked in. Oh no. This is salvageable. This is salvageable. Reverse. Level 6 completed. Level 7. I don't even know how long this version of the game is. I'm gonna assume that it's not as long as, like, Deluxe, obviously. I clicked outside the window again. Hey, I got the bonus though. Ah! Alright. Let's go. Level 8. Level 8. Why was 6 afraid of 7? Is 7, 8, 9. What's the deal with microwaves? What's the point in heating time? You know? Heat 60 seconds? Jeez. Oh no! 6 was afraid of 7 because 7, 8, 9. 10 was scared since he was in the middle of 9/11. Oh. Oh. Oh no. Almost there. Almost there. Alright. Alright. Yeah. 8 done. 8 done. I will continue. Oh no. I think I will stop at level 12 if I get that far. Because we're little over the hour mark. I think that's okay. I think like an hour and 30 minutes is pretty decent time. Ah, jeez. Right. Oh. Ooh. Let's go. And that'll be level 9 with change. Wait. Isn't this just level 5 again? I think this is just level 5 again. But it's like faster at that, at least. Top cap, how could you? I trusted you. This is super tight. Really. Yeah. Combo. No. No. I'm the winner. I'm winner. I'm winning. Oh no. Oh no. Oh no. No, 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 no. Oh. 2 lives left. When did I get an extra one? Alright. I'm not gonna bundle it this time. I'm gonna win. All those chain bonuses. Oh yeah. Oh dear. Didn't do that. Didn't do that. Oh. Oh. That's adorable. That's really good. Darn it. Darn it. I lost again, you guys. I'm losing. After that, like, 20 time, 23 time, like, chain bonus, you'd think, what? That's crazy. Because that would be expressing vulnerability. He couldn't do that. Yeah, that's it. That's it. Music is where you 1, don't try, 2, question mark, question mark, question mark, question mark, and 3, profit. It's the secret formula for success. Oh no. Oh no. Oh, this isn't looking good, guys. This isn't looking good. Oh. Oh. This isn't looking good though. I'm okay, but that's done at least. Oh no. Oh Christ. Okay. Oh no. Oh gosh darn it. Gosh darn it. I can't believe this. I don't know. One more and I'm out. This is game over for me. I was so close too. Oh no. It's okay. I'm locked in. We're gonna make this happen. Um. Oh, see, look, that one in the front. It's a reverse ball. So if I can get that, it'll move backwards. Because that's what reverse does. There we go. Find myself more time here. Oh my goodness. Oh my goodness. We are gonna make it. We are gonna make it. We are gonna make it. Oh my goodness. Ay, Dios mío. Okay. Um. mm, excellent. 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 Oh no. This is it. This is the run. This is the run. Fellas, this is the run. This is the run. Yo! Yeah! This is the run. This is the run. Yeah! No thanks, continue. Level 12. Level 12. I don't know how many levels are in this version. Like, I'm gonna assume that's, like, not as many as the full game, but... Bonus. Reverse. Wait, what was that about? Okay, I don't know. I'll just take it. I'll take it how it is. No, that wasn't well planned out. Okay. Oh no. Oh no. Oh no. Alright. Level 12. I guess there's 20 levels. That's my assumption. You know, if the preset high score is on level 20, I guess this version has 20 levels. But oh my goodness, Heroic Frog. Wow. Oh, the mode's in the full game. Okay. Wow. Wow, that was riveting. That was crazy, chat. That was crazy. All right. I believe that brings this stream to a close. As always, thank you for taking time out of your day to watch me write OCaml functions and then absolutely fail at Zuma Revenge. I appreciate it. Zuma's Revenge. Extremely good game. Both OCaml and Zuma's Revenge. All right, so I'll see you all next week, maybe. Depends if I do it again. But all right, bye.